So this is how they make all these margarines and stuff at room temperature, shortening. Tastes good. I give you that. It does taste good. All right, give me the products of these two reactions here. Can you draw them? This one's easy. Anybody do this one real quick? Oh, crap. What happens? Megan's question was, what happens? Well, our two hydrogens just join at either side, and then we get rid of that. So if that happens, what are we left with? What's the name of this? Not pentane, but cyclopentane, right? What do we get up here? What's the name of our product when we add hydrogen here? So we're going to add hydrogen and hydrogen. We'll come in here, in here. What's the name of that after we get done? Butane. We just make an alkane, right? Butane. Okay, fair enough? What's wrong, Allison?
I'm trying to catch up, trying to understand what you're saying. I'll still try to write this down, but it's kind of confusing me.
We're adding hydrogen to either side of the double bond. We break the double bond. If you'll listen instead of writing, it'll make more sense, because a lot of this is in a book, okay? If you're sitting there staring at your paper writing, you're not learning, okay? We're adding hydrogen. We're breaking the double bond, so each carbon gets another hydrogen. So this becomes butane. Same thing down here. Get rid of the double bond, add hydrogen on either side. Okay? Or you can go and download the slides for mastering as well. They're available in the study section of mastering. Now, hydration reactions. Remember I said we're going to write water like this. So on one side of the double bond, we're going to add hydrogen, and on the other side of the double bond is going to get OH. OHs make alcohol molecules, okay? We're going to learn about them next week. Like ethanol. Right? So, the question is, how do you know which side of the double bond the hydrogens and the OHs go with? It does matter. Here's the rule. Hydrogen goes to the side of the double bond with the carbon that has the most hydrogens. Think about it. He who has gets more, right? Rich people always seem to get richer, don't they?
That's right.
Poor people stay poor. So if you already got two hydrogens, you get another one. You only got one hydrogen? Sorry, you don't get another hydrogen. You get an OH. Okay? So let's do an example. Okay, we're going to do an example. Here we have 1, 2, 3, 4, 5. This is 2-pentene, right? Look at these two carbons. Which one has more hydrogens on it? Which one of these two carbons has more hydrogen? The ones in the double bond here. Which one has the most hydrogens? Right here. Which carbon has more hydrogens? Neither does. Don't y'all see that? They both have one hydrogen, right? Were y'all confused? You're trying to figure out which one, right? You're going, well, you said which one. It's got to be one of them.
That's right.
Neither one of them does it? So what do we do? In this case, it doesn't matter which side you put it on. Okay? You can put the hydrogen here or here. You get two different molecules, depending upon which one you put it on. Okay? So, or, like like that. Okay? This one could give either one of these two. I left all the hydrogens off. Okay? Because these two have the same number of hydrogens on them.
So can you back up?
Go ahead.
See through you very well.
So either one works. And we'll talk about how to name these next week.
So you're just adding the OH because it's a hydro.
This is a hydroxyl group. It's an alcohol. It makes it an alcohol.
Do you add the OH where you put the hydrogen?
No, the OH goes on the other, right? If I'm going to put, let's say if I'm going to put an H here, then the OH comes here, right? Versus if I decide that, versus if I want to put OH here, then this one gets an H, and the double bond goes away, right?
Oh.
Does it matter if they go on the same side or do they?
Doesn't matter, no, because now we have single bonds that are free to rotate, so it doesn't matter which side you draw it on. Now this one, where's my hydrogen going to go? It's going to go on the left or the right? The hydrogen's got to go on the right. We're going to make put a hydrogen here and an OH here, and the double bond goes away. So it's a single bond now. Okay? That's called hydration reaction because we're adding water to it. Okay? So we have hydrogenation, adding hydrogen, and hydration, adding water.
And how did the second one end up having the same answer?
Do it?
Didn't the bottom one not have the same answers?
What do you mean?
What you just did?
The same answer as what?
OH is on the left and H is on the hydrogen on the right of the bond?
Right here, yes.
Yeah.
The same answer as what?
The one on the top.
No, this molecule is different. This has 5 carbons in it. This one only has 4. It's not the same
Like a
answer.
placement.
I'm not sure about your question. These aren't the same answer.
You said the hydrogen, you decide which side the hydrogen goes on based on the side with the most hydrogens?
That's right. So down here it matters. Up here it doesn't matter. You could actually have 2 different answers up here. Down here it matters.
Okay, so if the carbon and hydrogen on the left of the bond was CH2, then in that case, the added hydrogen would be on the left.
That's right.
Okay,
Yep.
all right.
Okay. Last section. Aromatic compounds. Look at this molecule up here. Here we have a ring structure that has 6 carbons in it. And look at how many double bonds are in that structure. There's 3 double bonds, okay? And I want to show you that if I draw it differently, right now it's drawn like this, right? You could also draw it like that. So if I could move these double bonds like that, okay?
And it will be the same.
And it's the same. This particular molecule is called benzene, okay? And as it turns out, it's a flat molecule, and we often represent it by drawing it like this. Because what this means is that how many electrons are contained in those 3 double bonds? There's 6 electrons there, right? There's 6 electrons in these 3 bonds. Those 6 electrons are actually shared all the way around the ring. They're not isolated between 2 carbons, okay? This is like a commune, right? They share those 6 electrons all the way around. It's a very stable thing, okay? It's very, very good, okay? So we often will draw it just like this, as a 6-member ring with a circle in the middle, indicating there's 6 electrons being shared right there. Okay, this molecule is called benzene. It's very common And these are called aromatic compounds. Where do you think you find aromatic compounds? Anybody? Look at the word.
In that area.
Not in the air necessarily, but sort of
In gas form.
Perfume.
in things that have an aroma. I.e., let's talk about cooking. Vanilla, cinnamon, hormones. Yeah. Chemistry joke time. This is benzene, right? What is this? No. It's Mercedes benzene.
Good job.
I'm thinking peace. You're thinking Mercedes, who's the rich one?
That's it's in the middle is a symbol for Mercedes, right?
It is.
Bottles of peace sign.
I thought it was peace. That's what we saw. We don't drive Benzes.
Neither do I. I don't. You can find my vehicle on campus. I'm surprised y'all don't know what I drive. I mean,
You're not stalkers.
You used to have a bug.
I used to drive a bug, yes, but I don't drive a
Oh,
bug.
I said bus.
My bug died. No, my truck's not a Dodge.
Okay. So you have cut.
I do drive a truck.
Yeah, you definitely.
If you find a truck on campus that has, if you find a truck on campus that has Walter White on the back of it, Heisenberg, you'll know where my truck is.
Walter White, Heisenberg.
From Breaking Bad.
Oh.
I'm gonna look for it. What do you
Huh?
like? I'm gonna look for it.
In the parking lot,
Between 5 and minutes.
somewhere.
Are you not gonna leave us and run, what's his name? You have a student like him too?
No.
Okay, good.
I have a couple that ask me that I, ever thought about doing that. I'm like, no. We're not going to jail, sorry. Here's some common aromatic compounds. These are toluene, aniline, and phenol are all compounds that are used as precursors to making other things when we synthesize molecules. The other thing that's true about them is they tend to be very carcinogenic. What does that word mean?
Cancer causing.
Cancer causing. And the reason it's, I think the most recent research into it says that the reason is because it fits into your, everybody knows about DNA and RNA, right? They're chains, and they have the bases in the middle. Those bases are also have aromatic rings in them, and they fit in there, and they disrupt it, so when it replicates, it creates a mutation in the gene sequence, and that can cause cancer sometimes. And so these guys are all carcinogenic when
Is
you
that
work
first
with
one, is that a paint thinner, like a paint thinner?
toluene. Yes, is used as a paint thinner sometimes. Yep. You're really not supposed to get it on you. Definitely shouldn't ingest it. It's very toxic.
Smells horrible.
Smells horrible. You should wear a respirator when you work with it for sure. Yeah. Phenol also has a very distinct smell. We're not going to worry about naming these guys. Just know that you can number things just like you would on a ring. This is 1,2-dichloro, 1,3, and 1,4. The old way of naming these, you might see the words ortho, meta, and para. Ortho means that they're next to each other. Meta means they're kind of diagonal, and para means they're across from each other. So if you see those terms, you might, that's what it means. Don't worry about naming all this stuff. Here's a common benzene-containing compound. This is toluene. Oops. If I get rid of the three things on here, that would be toluene with just a methyl group up there. But these are called nitro groups. This is TNT, 2,4,6-trinitrotoluene, TNT, right? Not Turner Network Television, but what is TNT?
AC/DC songs.
It's an AC/DC song. It's also a what?
Explosive.
It's an explosive, right? That's why AC/DC wrote a song, right? It was explosive.
Oh, is that why, like, the cartoon, the coyote and...
And you see TNT on a little thing? Yeah, exactly. That's the compound. That's TNT. Yeah, we're gonna blow up the Roadrunner.
That's
Yeah.
the Roadrunner.
Yeah, Coyote's trying to blow up the Roadrunner. He's got a pile of TNT there, right?
Can't believe that's in that.
I know they are kind of young for that, aren't they? Here's some other larger molecules that all contain aromatic rings in them. If you've ever smelled vanilla, you know it has a very distinct smell, right?
Yeah.
I think everybody smelled vanilla, right? But it has a benzene ring in the middle of it. Ibuprofen and acetaminophen, aspirin, all these are NSAIDs, right? And they all contain benzene rings in them as well. High doses are toxic. Lower doses are often used as anti-inflammatories. What would high doses constitute as? I'd probably take high doses. Yeah. I take, I don't take how much ibuprofen I take a day. It's probably not legal. Huh?
More like 8 be a high dose.
800 milligrams a day.
No, you can take, well, you can take.
I take 800 at a time is one Motrin. I take probably 2,400 or so a day a lot of times. My knees hurt. My knees hurt. Yeah. It's also an acid, so it's not good for your stomach as well. See this group over here? We're going to talk about these in the coming weeks too. This is called a carboxylic acid. This hydrogen comes off of here. This one is an acid. Aspirin's an acid too. It gives up that hydrogen, so these guys eat away at your esophagus over time as well. Yeah, not good for you.
They weren't gonna like BCs
Yeah. Well, BC is aspirin, isn't it?
and caffeine and other
Yeah.
things.
We're not going to worry about naming these guys. How's that? I think we're done.